Everyone. In this, we will see the next problem, which is a reorder list. So this concept is related to linked list. Uh, so let's see our question and then solution. And in this, I will tell you three approaches, but here we have done only the efficient approach. But I will going to discuss the other two approaches as well. So you are given a head of the singly linked list, and the list can be represented as L0, L1. These are the links. So let me just annotate it. So these are nodes and these are links. So here L0, L1, L2, L3, Ln minus 1, Ln. So reorder the list to on the list to be on the following form. So we have to reorder this list in such a way that we get this way: L0, Ln, which is last one comes here, and then next one comes here, and again last one comes here, which is Ln minus 1, and next one L2 comes here, and the last one, like which is previous to Ln minus 1, is Ln minus 2, which will come here, and then L3 comes here, and so on. So you may modify the values in the list nodes, only nodes themselves. You may not modify the values in the list nodes. Only nodes themselves may be changed. So here you should not modify the values. For example, here in this case, in this example, you should not modify. So here we should get one. We will get 1 as is, and the last one is 4, and then 2 and 3. So in this you should not change the values in such a way that, like, keeping the linked list same way and exchanging these two variables values. If you exchange these two variables values, it will become 4, and this will become 2, and then again afterwards exchanging these two values in these nodes. So that we should not do. We have to modify, we have to change nodes themselves. So we have to move whole this node to this place, and hold this node to this place, and hold this node to the ending place. So we have to do follow this this approach. So yeah, so this is our second example. Let's see our one more example as well. So here you can see we were given 1 2 3 4 5, which is 1 2 3 4 5, and our answer should be 1 will come as is, and then last one comes as is here, and then next node come here, and then last node we have already taken. So this last but one node come here, and the next node from beginning, it will come here. So this is how it should be, our answer should be. So in output we will be having 5 2 4 3. So this is the logic. So we have to solve this problem. So the constraints are: number of nodes in the list, linked list is in range 1 to 5, 5 into 10 power 4, and the node values will be 1 to 1000. So node value doesn't matter for us. So these two constraints will not bother so much to us. So we'll directly go to the solutions. So before going to the this solution, as I said, I'll first explain the three approaches. So let me just take the three approaches paper, which is here. So here you can see, let me take the, while explaining it will be useful. Let me take this to here. And what I was saying is, the first method is brute force method, which is to which is for example, assume this is our input. So here I have taken 10 nodes in linked list. So brute force method is we will start the for loop from here, and next for loop we run from here, and we go till the last node, and then we attach this last node to last node here. Then next again we will the for loop, our external for loop go moves forwards, and when it move forwards it will come to 10, and we'll ignore the 10, and we'll again move forward. And then from here again internal for loop starts, and it will start from here, and it will go till last node again. So it will go till 9 last node, and we will again point this node to this node at this place. At this place we will be pointing that node, and then next we'll be moving forward with this node 9. 9 will be here, so we'll not will be moving forward till 3. And then afterwards we will run if internal for loop again from 4, and we will go till 8, and we which is last node, and we will move to here. So this is how we follow. So this will take order of n square time. The reason is we are using two for loops. One is iterating externally, and one more is internally iterating, internally going from then if for loop started from here, external for loop started from here, internal for loop start from next node and till goes till last node. And this and again external for loop comes here to next node, and again internal for loop start from next node, and it will go till end of node, end of the linked list. So that is the reason it will take order of n square. So the like in actual it will the external for loop goes till 5 only, till fifth half nodes only, because we are moving one from last to half nodes. By the time the node external for loop reaches here, we'll be moving half nodes to here, where we will be merging. So that is the reason external for loop run n by 2 times, and internal for loops run every time it runs, like average it will run n by 2 times. So that is the reason the time complexity will be n square by 4. And the dominating term here is order of n square. So that is the reason we will be taking this one. So this is our first solution. We'll repetitively iterate till the last node and attach it to beginning. This is our method 1. The second method is dynamic programming. So I'm not sure if I can call this method as dynamic programming, but this is similar to using extra space to avoid the time complexity. So that is the reason I'm like calling it dynamic programming. So here what we do is the time complexity becomes order of n, and space complexity becomes order of n. What we are doing here is what we are doing here is we are just going till mid of the till middle of the element we are going, and from then onwards in a stack we'll be storing the other half links. So other half nodes address we will be storing in a stack. For example, assume this node has address of 600, 101, 102, 103, 104, 106, 5, etc. Then we'll be from here onwards we'll be storing in stack which is 101, 102, 103, 104. And while popping we'll be popping the last element, and we'll be again starting from beginning, and we'll be attaching one by one node. We'll be popping from this stack, and we'll be attaching to the nodes, and we'll be going moving forward and attaching the next node, popping the next node, and we'll be attaching next node and moving forward, and same we are doing the same thing. So that is the reason here this for stack will take order of n by 2 space, and the time complexity takes order of n, because for moving to half it will take n time, and again we'll start from beginning and we pop one elements and we attach in middle. So for that it will take order of n, so which becomes to order of 2n. So the dominating term will become order of n. So that is the reason time complexity is order of n, and the space complexity is order of n. And the next method is which is the efficient method, and here its time complexity becomes order of n and the space complexity is order of 1. So in this what we'll do is this is the approach we will be going to discuss in this solution. So in this approach what we'll be doing is we'll be like this method will be going till middle, and from middle to end, after going to middle we'll be breaking this and it will become two linked list. And the second what we'll be going to do is we'll reverse the second linked list. So it will become from 10 the second linked list become reverse, like 10 will point to 9, 9 will point to 8, 8 will point to 7, 7 will point to 6. So after that we'll be merging, so we'll be one iteration start from one head start from here, one head start from here, and we move forward each these pointers move forward in each iteration, and we'll be merging these two linked list and we'll be getting this our answer. So since we are for traveling to middle it will take n time, and for reversing the linked list it will take n time, and for merging it will take n time. So total 3n time, so which dominating term is n, so that is the reason time complexity is order of n. And here we are just using some 3 to 4 links, extra links, so which is constant space, so that is the reason space complexity is order of 1. So if you didn't understand this method 3, you no need to worry, I will be going in detail. So let me just clear all this, and let's go through the solution 3. Yeah, so let's go through our solution from beginning. So initially we get one linked list, which is assume like here we have taken and also in question it is given that we no need to return anything, so we just have to modify existing linked list and that's enough. So that is the reason here we are not returning anything. So initially we get the linked list. So initially we get the linked list here, and we'll be going inside, and initially we check the two condition which is just let me clear this thing, why it's not coming. Just remove this one so that we can see question also. Yeah, that's good. Yeah, so let me annotate it again. Yeah, so initially we get the linked list, and we are checking here condition, like if we were given the linked list size maybe 1 to 1000. So that is the reason if there is only one node, we no need to do anything, just we can return as is. Or if we have two nodes, for example 2 nodes, then in this case also we no need to return anything, because like we'll be taking first node and we'll be attaching last node to first node. However, we already have the same thing, so we will not be doing anything. So that is the reason we return we will not be doing anything. So that is the reason here we have this if condition. So if there are only one node or two nodes in a given linked list, will not be doing anything at all. So then if given nodes are more than two, we will be doing this logic. So let's take this example, which is given input 1 will be having 1 2 3 4 5 6 till 10, and here we have attached, so 1, then 10 comes here, 2 and 9 comes here, 3 and 8 comes here, so on. So this is our answer. So like and in example 1 I have taken only 9 nodes, so 1 comes here, 9 and 9, and last one comes here, and the next one 2 comes here, and the last one comes here. So same way we have this for 9 nodes we have this answer. So here in this solution we'll discuss this example 1. So initially we get this linked list, and our goal is to convert into this linked list. So initially we the same linked list I have taken here. So we have this linked list, and initially here we point fast and slow to head. Fast and slow we will be pointing to head. So using concept of fast and slow mover, we'll be finding out middle point. So this concept, as I think you may know, like in each iteration will be in for a while loop. In each iteration slow will move only one node, and fast will move two nodes. So here slow is moving only one node. When slow comes here, uh, initially slow and fast start here, slow comes here, fast will come here. I mean from here to here it will come. When slow moves to here, fast will move to this point to this fifth point, and slow moves to fourth point, and fast move to seventh point. When slow moves to 4 to 5, fast moves from 7 to 9. So here it will end, because here we are checking fast next and fast next should be present, otherwise this condition becomes false. Here fast next is 10, it is present, but fast next is 10, and fast next is none. So that is the reason it will not go inside this while condition. So here fast stops here and slow stops here. So this is our midpoint. We got the midpoint. So we have found the midpoint, and once we find the midpoint, we will break this linked list into two. So what we are doing here is we are just here assigning one head to slow next, which is we will be attaching head to slow next is 6, so we will be attaching, and slow next to none. Slow next becomes none, so that is the reason these links get broke here. So then next we are at next we have done the second task, which is to break the linked list into two linked list, and then we'll be reversing second linked list will be reversing. So we have this linked list, so we reverse it and we will convert it to this linked list. So what we will be doing here is here we are assigning current to head next, which is current will attach to 7, and head next to none. So head next to none, initially we will be assigning head next to none, which this after these two steps it will become linked list become this way. Current will be pointing to 7, and head 2 will be pointing to 6, and 6 will point to none. So then we will go inside this while condition. In each iteration what we'll do is we'll reverse the linked list. So we go inside while loop. Current 2 is present, yes, we'll be going inside while, and in while we are attaching current next to head 2. So current next get attached to head 2, and then head 2 equal to current next. So current head 2 becomes current next. current next. Here I haven't shown, but after head to become current next, so when head to become current next, so head 2 will be pointing to 8 and current 2 will be pointing to 7, and we are swapping those two variables, we are swapping here. So that is the reason uh, here current 2 becomes head 2 becomes current 2, so these two get swapped. So that is the reason when head 2 was pointing to 8, it will now point to 7, and current 2 was pointing to 7, it will point to current 2. So this is the step we follow till end of the linked list. So in next again will be current 2 next becomes will be pointing to 7, and head 2 will point to 9 again, and these two will get when current 2 and head 2 will get swapped, and in next again current to current 2.2 current 2.28 and head to 1.10, and this will again 2 will become exchange, where head to no 0.29 again, current 2.10, and again current 2 is present, so current next 0.29 and head to 0.2 none now, and again they will exchange here, current 2 becomes none and head 2 will point to 10. So that is the reason here head 2 is pointing to 10, and we got this answer, all linked list is became reverse, and current 2 becomes none. So that is the reason it will not go inside while again, so this iteration will end here. And then we got two linked list, one is head is pointing to this, head 2 is pointing to second linked list. So now we'll merge these two linked lists. So here in this next iteration we do this thing. So now current to for our current to point to head to, which is like current to point to head to, for our easy purpose, assuming here I am assuming head 2 as h2, current 2 as c2, current 2 next as c2 next, h2 next as head 2 next as h2n. So initially we got these two arrays, which is these two linked list, this linked list I have written here, and the second linked list I have written here. Initially head is pointing to this, and current 2 is pointing to this, because here we have uninitialized, and h2 is pointing to 10, because this is what I have written here. And then we check if current 2 and head 2 should present, this should not be none. So this is true, because current 2 is present, head 2 is present, it will go inside if condition, else while condition, if it will go inside while, and then what it will do is two variables which are current to c2n h2n, c2n point to c2n point to c2 next, and h2n point to h2 next, h2 next. So here h2n pointing to 9, c2n pointing to 2. Then next what we'll be doing here is current to next equal to h2. So for easy purpose I have again drawn one more linked list. So initially we have one, and what we are doing here is current to next current to next equal to head 2. So current to 2 is 1, next equal to head 2. So that is the reason one is pointing to 10. Then head to next equal to current to c2n. So h2 now h2 will point to head 2 point to current to next, so which is 2. So in this case what happened, initially this point and this will break, because one will pointing to 10, and then next 10 is pointing to 2, so this link will get break. So next till here we have completed, and now current to moves forward and head to moves forward. So now this will go head to moves here, and c2 moves here, And next in iteration again, current 2 is 2, head 2 is 9, both are present, so it will go inside while condition. And again c2n and h2n will point to next elements, because here that is what we are doing here in these two steps. And now c2n point to 3, h2n point to 8. So next here what we are doing, c2 next is equal to h2. c2 next is c2 next c2 is 2, c2 next is h2, h2 is 9, so and it will point to 9. So breaks this link breaks and this link forms. And next what we are doing, h2 next equal to c2n. H2n is sorry h2 h2 next equal to c2n. h2, what is h2 here? 9 is h2, so h2 will be pointing to c2n, which is 3. So this will get breaks now. And then next what we will be doing, will be current c2 and h2 will be moving forward. So now c2 will come here, and h2 will come here, and in next iteration these two are present, 3 and 8 are present, node are present, not null. So again go inside file, and next assign c2n h2n. c2n is 4, h2n is 7. And then next what we'll be doing, c2 next, which is 3 next, will become h2 which is 8. So this will get broken, and h2 next will becomes c2n, which is 4. So that is the reason here we get 4. This links forms and this links get break. And then next will be c2 and h2 will be moving forward. So we c2 comes here and h2 comes here. And then next in again this will while condition will check c2 h2 are present, 4 and 7 are present. So we'll be going inside while condition, and we'll be assigning c2 h2 c2 next, and h2 n2 h2 next. So next what we'll be doing, c2 next will becomes will point to, which is 4 will point to h2, so which is 7. So this link get breaks, and h2 will point to c2n. So in this case this links get breaks. And then next again c2 h2 comes forward, so c2 comes here, h2 comes here. And again these two nodes are present in next iteration, so again it will go inside while condition, and c2n and h2n will point to next, which is none in this case, because 6 next is none, 5 next is none. So it will come here, and c2 next will point to now h2, which is 6. So that is the reason 5 point to 6. And h2 next will point to c2 next, which is none here, c2 next is none, so 6 will point to none. And these two variables comes move forward, which is c2 comes here and h2 comes here. And then next if while condition becomes false, so it will not go inside for loop. So sorry, while loop, and we got this our required answer. So this is how we will get answer here. This seems a little complicated than the other two methods, especially the second method, but this will take very less time, because here this is taking order of n, and this is taking just one time complexity, and internal things also here taking order of 1, and this one takes order of n here again, and the last while loop will take order of n here. So total of order of 3n, and dominating term is like all these internal statements are like just assigning, so order of 1 times complexity, so total of order of 3n, but dominating term is n, so time complexity is order of n. And the space complexity here is we are using here two extra variables, and here one more variable, here one more variable, and here just two more variables, just around the 5 variables, so which is constant space. So order of space complexity is order of 1. So this is our solution. So I'll share this I'll put these two images in GitHub or somewhere and post the links in YouTube description. And also I have uh, shared this solution here in lead code. So here I have mentioned time complexity and I have shared this solution. So I'll post the link of this lead code solution also in description. I'll put those two links. I hope you understood the problem, and yeah, that's it. Thank you so much for watching.